Hey guys, this is Mr. Gucci with your help video for your Unit 2 problems from the midterm review packet. Remember, your goal is to try the packet on your own first. First doing it based purely off of memory, what you can remember, then attempting it using your open notes, and finally, lastly, coming here to check your answers when you're done. You should not be here until you've already attempted these problems and are now checking your answers. Well, we have the multiple choices answered here along with explanations at your disposal. Feel free to read those and those explanations. And if any of them don't make sense, then come with questions to next class to ask me. Now let's dive into the free response questions, all right? Let's get to it. An object is immersed in water. That means dunked in water. The water volume increases from 24.5 milliliters to 35.8 milliliters. What is the volume of this object? Well, this right here, folks, is an example of the Archimedes principle, where when you dunk something in water, the amount of water that it displaces equals its own volume. So for this, we just need a little bit of subtraction. The volume of an object is equal to the final volume minus the initial or starting volume. So the volume is equal to 35.8 milliliters minus 24.5 milliliters, all right? So what does the volume equal? Volume equals, let me hit the calculator. 11.3 milliliters, all right? 11.3 milliliters. That is the volume of this object. It's a really great strategy to find the volume of awkwardly shaped objects like hunks of metal or coins, all right? An object has a mass, so on to the next one. An object has a mass of 24.5 grams and a volume of 10.3 milliliters. What is the density? Well, this is another equation that we worked with in class, all right? Specifically, we use this with finding the density of metal coins to determine their identity, as well as we use this equation when finding the thickness of foil. All right, density is equal to the mass of an object divided by its volume. All right, density equals mass divided by volume. So the mass of this object is 24.5 grams. And the volume is 10.3 milliliters. Now, the units going in don't really matter. Any mass unit divided by any volume unit will get you density. So I plug this into a calculator, and I get the density of this object is 2.38 grams per milliliter. All right, because we did grams divided by milliliters for the equation, our units are also grams divided by milliliters. A piece of aluminum yarn has a mass of 10.797 grams. Aluminum's density is 2.69 grams. What is the volume of this piece of aluminum? This now, my friends, is going to involve a bit of algebra. You can bet the midterm will have some algebra. So I'm going to get a sheet of paper. Oh, hello, Puffin. And I am going to work this problem out. So again, problem 9. That sucks. That's a bad 9. Problem 9. Density is equal to the mass divided by the volume. Now, in this case, we know the density. The density of aluminum is 2.69. And that's equal to a mass of 10.97 grams divided by this volume. Well, we got to solve for the variable on the bottom of a fraction, which can be, granted, annoying. But there are some strategies that you can use. What I like to do is I like to... Can I click this? Can I click this? You can let me click it. I like to put this number over 1, and then I like to use cross multiplication. So 2.69 times V is equal to 1 times 10.97, or just 10.97. This computer doesn't come with a little touch doodad, and so it's hard for me to write. Now to solve for v, to get it by itself, we divide both sides by 2.69. I apologize for my poor handwriting. So 10 divided by 2.69, what does that equal? Well, I'll plug it into my calculator. All right, let's see here. 10.97 divided by 2.69, and we get that the volume of this sample of aluminum is 4.08 milliliters. 4.08 milliliters, right? That's the answer, 4.08 milliliters. Let me get the test back here. Very good. 4.08 milliliters. So that's an algebra problem you will have to set up. All right? Number 10. What is your percent error if you record a mass of 13.43 grams, but later measurements established that the actual mass was 14.01 grams? So, percent error is another formula that we discussed. All right? Percent error is equal to the actual value minus what you got divided by the actual value. All right? The whole thing must be encompassed in absolute value lines. All right? Remember that for percent error, you can never get a negative. It must always be a positive error. It doesn't matter if you were off by more or less. What matters is how far off you were. So percent error equals, let's figure this out. The actual value was 14.01 minus 13.43 divided by the actual value, which is 14.01. So when I plug that into a calculator, what do I get? I get, for my answer, get out of here, kitty cat, 0.0414, which as a percent is equal to, bounce that decimal twice, 4.14% error. Hey, maybe not too bad. I don't know. Is it good? Is it bad? It depends on the circumstance, all right? Number 11, what is your percent error if you determine the density of aluminum to be 2.98 grams per milliliter, but the actual density is 2.69? So, again, identical type of formula as above here. You just plug it in. All right. The actual density of aluminum is 2.69. All right. You got 2.98. Dividing it by the actual 2.69. So I plug this into the calculator and I get, negative 0.108. All right, which would be negative equal to negative 10.8%. But remember, it cannot be negative. It must always be positive. So the answer is 10.8% error. There we go. I hope this was helpful to you.